Okay, in question 5 of practice question, this is actually a H2 Maths past year exam question, but it is also applicable to H1 Maths. So you have the 5 digits 1, 2, 3, 4, 5. They are arranged to form a 5-digit number. A 5-digit number. No digit is repeated. Okay, in other words, no digit is reused. So every digit is used and there's no repetition of digits. So part 1, find probability that a number is greater than 30,000. So, okay, let's do a representation. So there are 5 digits. So which digit will matter to cause the number to be greater than 30,000? So it is just the first digit. So the first digit must be either 3, 4, or 5. Alright, in order for the number to be greater than 30,000. So we have 3 choices for the first digit. Alright, so for the second digit, we are left with 4 digits to choose from, and for the third digit, we are left with 3 digits to choose from, and for the fourth digit, we are left with 2 digits to choose from, and for the fifth digit, we are only left with 1 digit. Okay, so 4 times 3 times 2 times 1, or is the same as 4 factorial. Okay, so for part 1, the required probability would be 3 times 4 factorial. Alright, then remember we are calculating probability, so you need to divide by the denominator will be the total probability of the 5 digits. The permutation of the number of ways, total number of ways to permutate that 5 digits, which are all distinct. So it will be 5 factorial. Okay, so press your GC and you can get the answer. Part 2. The probability that the last 2 digits are both even. So if you want the last 2 digits to be both even, so it will be the last 2 digits that matter. So for the fourth digit, the second last digit to be even, so it can be either taking on digit 2 or 4. Then for the last digit, if the digit 2 is already chosen, then you are only left with the digit 4. Or if for the second last digit, if the digit 4 has been chosen already, then you're only left with the digit 2 for the last digit. So therefore, the last digit only one choice. And the second last digit, you can choose from either 2 or 4, so there are 2 choices. So for the first digit, you have 3 choices, second digit 2 choices, and third digit 1 choice. So 3 times 2 times 1 is the same as 3 factorial. So therefore, the required probability will be 3 factorial times 2 times 1. Okay, the times 1 you can don't write. So likewise, divide by denominator, which is 5 factorial, which is total number of ways to permutate 5 distinct digits. Okay, part 3. Find the probability that the number is greater than 30,000 and odd. So greater than 30,000 and odd. So you must satisfy both conditions. So I can break it into 2 cases. So case 1 is, so what matters will be the first digit in order for the number to be greater than 30,000, and in order for the number to be an odd number, what matters will be the last digit. So case 1, first digit is 4 and last digit is 1, 3, or 5. Right? So that's first case. So for this case, if the first digit is 4, so there's only one way. And the last digit is 1, 3, or 5, so there are 3 ways. Then second digit will be 3 ways, 3 choices, third digit will be 2 choices, and fourth digit will be 1 choices. So in other words, 3 factorial. So the number of such numbers will be 1 times 3 factorial times 3. Alright? Okay, so that will be for case 1. For case 2, in order for the number to be greater than 30,000, my first digit can, other than taking on 4, can also be taking on 3 or 5, and my last digit, in order for it to be an odd number, it must still be either 1, 3, or 5. Okay, so now let's look at this. There's a bit of overlap now. So if my first digit is 3 or 5, so in order for the number to be greater than 30,000, so I have 2 choices. So my last digit, it can be 1, or it can be 3 or 5. So if my first digit chosen is the number 3, then my last digit I can only choose from 1 or 5. Likewise, if my first digit chosen is the number 5, then my last digit I can only choose the number 1 or 3. So therefore, my last digit I'm left with only 2 choices. And my second digit I have 3 choices, third digit I have 2 choices, and fourth digit I have 1 choice. So 3 times 2 times 1 is, again, it is 3 factorial. So how many of such numbers do I have in case 2? So it will be 2 times 3 factorial times 2. Alright? Okay. So now, in total, now I'm ready to go and work out what is the required probability. Okay, what is the required probability for part 3? For the probability that the number is greater than 30,000 and odd. So I just go and sum out. Okay, so how many of such numbers do I have? So I go and sum out in the numerator. And then denominator divide by total number of such numbers, which is 5 factorial. Okay, so press your VC, you can get the answer, which is 0.35. Okay, so that will be how you work out question 5.